Hello everybody, we're going to talk about solving quadratic equations again. Now, we're going up another level here where we have, now we do have a constant term. So if there is a quadratic term, a linear term, and a constant term, we need to do something a little bit different. But first let's look at this one. This one we already know from the zero product property, right? The zero product property. Short name for that is ZPP. That if two things are multiplied together that equal 0, so A times B is equal to 0, then A can equal 0, or B can equal 0, or they both equal 0. So A equals B equals 0. So right here we have two things that are multiplied together that equal 0. It's just like this blob times this blob is equal to 0, so that means this could be equal to 0, right? X minus 3 could be equal to 0, or x plus 2 could be equal to 0, would be solutions to this. So let's try this one. So what minus 3 is equal to 0? That's going to be positive 3, or I could do it the old-fashioned way, add 3 to both sides, and I get x equals 3. And something plus 2 is equal to 0. That would be negative 2, but the old-fashioned way, subtract 2 from both sides, I get x is equal to negative 2. So these are my two solutions that would make this statement true. So I could just plug in 3. Let's see, 3 minus 3 is 0, and then 0 times whatever this is. Actually, it's 5, right? 3 plus 2 is 5. So 0 times 5 is equal to 0. That's true. Or I could put again negative 2. So negative 2 minus 3 would be negative 5, and then negative 2 plus 2, that'd be 0. So negative 5 times 0 would be also 0. So those two check out. Now, what I want to do is actually multiply out these two binomials. If you remember, we multiply x minus 3. So let's take our algebra tiles out. Times x plus 2. And let's see, what would it be? So x plus 2 would be x squared plus 2, and then negative 3. Let's see, it goes this way. Right, so on the top I have x minus 3, x plus 2, and then I'd have negative 3 times positive 2 would be negative 6, right? So multiplying that out again. And I know you guys know this already from our factoring module earlier, but I just want to kind of refresh our memory here. Let's see, do I have any more ones? There we go. So this would be equivalent to x squared minus x, right? So negative 3 and positive 2x, two of these cancel out to leave just a minus x. These are my 0 pairs. Minus 6, right? Minus x minus 6 is equal to 0. And so this equivalent expression, x minus 3 times x plus 2, is equivalent to x squared minus x minus 6. So that gives me a little hint on how I can solve this, right? If I turn this equivalent expression into x minus 3 x plus 2, that's an equivalent expression to that. So now I have something I can apply the zero product property to, right? ZPP. So I know that x is equal to 3 or x is equal to negative 2 will be solutions to this original equation. So let's go ahead and check it out, see if it's actually true. So 3 squared minus 3 minus 6, is it equal to 0? 3 squared is 9, minus 3 minus 6, so 9 minus 3 is 6, 6 minus 6 is 0, so that checks out. This negative 2, let's check it out. So negative 2 squared minus a negative 2 minus 6, is that equal to 0? So negative 2 squared is positive 4, negative 2 is plus 2, and minus 6, is that equal to 0? Yeah, 6 minus 0, or 6 minus 6 is 0. So that checks out. So that gives us a little hint about this. If we can factor this part and turn it into an equivalent expression that is a product of two binomials, then we can set each part equal to 0 and solve it that way. So let's go ahead and do a couple more. So is this one factorable? Well, let's see. What I want to do is think about what two numbers do I multiply to get 9, but when I add, it's 3. So I like to use this kind of big X, I call it. So what do I multiply to get 9? And when I add, it's 6. So let's see, 1 times 9. No. 3 times 3. Yeah, that works. So 3 times 3 would my factors be 3x and 3x. So when I go to my general rectangle, it's x squared, and then 3x times 3x plus 3x is 6x, and then 3 times 3 is 9. So this would be x plus 3, x plus 3. So my factors are x plus 3 times x plus 3. Or I could write it like this, right? X plus 3 quantity squared is equal to 0. So what makes this 0? Negative 3, right? Negative 3 plus 3 would be 0. So x is equal to negative 3. Or this one also is negative 3, right? This happened because this was a perfect square. But since I have two different answers that are actually the same answer, I really only have one solution to this equation. So it's just x minus 3. Okay, let's go ahead and do one more. So I'm going to factor this one. Let's see, what do I multiply to get negative 15? But when I add, it is 2. Let's see, 1 and 15. And one of them has to be negative. That's definitely not 2 apart. How about 3 times 5? Oh, there we go. Those are 2 apart. One of them has to be negative. So I want to end up with a positive 2. So that means this one needs to be negative. So I have negative 3x and positive 5x. So my general rectangle would be x squared minus 3x, 5x, right, is my split, and negative 15. So this would be x and x. Greatest factor is an x, so then this would be minus 3, and this would be plus 5. So this would be x minus 3 times x plus 5 is equal to 0. Oops, I forgot to put the equal to 0 there. And that would mean that x would have to be equal to 3, or x equals negative 5 will be solutions to that. So let's go ahead and check this one. 3 squared is 9, plus 2 times 3 minus 15 is equal to 0. So 9 plus 6 minus 15 equals 0. Yeah, that checks out. And then negative 5 squared would be positive 25. Negative 5 times 2 is negative 10. Minus 15, is that equal to 0? Yeah, so this is 25 minus 25. So that checks out. Okay, so these are my two solutions to that quadratic equation.